Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on integration by parts, and in this video I'm going to talk about how to deal with integrating by parts when one of the functions is a ln. So here we're going to integrate x ln x with respect to x. Now, if you take the normal strategy, which is the simple bit's u, we would be saying that u is x, and that dv dx is ln x. And what I just want you to pause and think about is, what's the problem with taking this approach? So the problem is, we don't know how to integrate ln x. So we are struggling to get an expression for v. So we don't do it this way. So rather than saying that x is u and ln x is dv dx, we're going to say that x is ln x and dv dx is x. So this is the exception. You call the easy bit u unless there's a ln, in which case u is the ln bit. So if u is ln x, then du dx would be 1 over x, and if dv dx is x, then v would be a half x squared. And this may look like, hang on a minute, this is getting a bit more complicated, but stick with it. Now, remember, good habits. We write out the formula for integration by parts. We do it correctly, obviously. The integral of u dv dx is equal to uv minus the integral of v du dx. So the integral of x ln x with respect to x is equal to uv. Right, uv, ln x multiplied by a half x squared. So right, that's half x squared ln x minus the integral of v du dx. So v du dx, so it's half x squared multiplied by 1 over x. And actually, that's okay, because just pause a moment and think, what's going to happen to this? Well, the answer is, it's going to simplify, because we have a half x squared multiplied by 1 over x. So that is going to simplify to a half x. This bit here, 1/2 x squared ln x, remember there's no further integration required of that bit, we're just looking at integrating this. So all we have to do now is integrate a half x squared with respect to x. So, a half x squared ln x hasn't changed, minus integral of half x, which is 1/4 x squared, and then not forgetting the plus c. Okay. So, key thing to take away from that is, with integration by parts, you call the easy bit u unless there's a ln, in which case you call the ln bit u, and then because we will always get a nice 1 over x expression here, we're going to get some neat cancelling going on with our second integral and get something quite pleasant. Right, join me in the next video where we'll look at integrating by parts twice.